what's nice is that Python actually has not only strs or strings as first-class objects that come with the language itself. Python itself as a language is known as an object-oriented language, and it has other features as well. And some of you in high school, if you ever studied Java or the like, you might already know about object-oriented programming, otherwise known as OOP. And what this is sort of referring to is a new and improved version of C structs. Recall that in C we had structs, whereby we could create our own data types for like persons or nodes, for instance, by creating our own data types that have one or more other values inside of them. Well, what C doesn't offer you, at least not easily, is to associate functionality with those structures as well. For instance, for a person object, wouldn't it be nice if there were a function, especially if running the code on your phone, that was a call function that would just automatically call that person, or an email function that would just automatically email that person if we're keeping track of their email address as well? Well, you could implement a call function and pass the person in as input. You could implement a call function and pass the person in as input, and then it would work. But wouldn't it be nice to sort of associate more tightly and encapsulate related functionality, just like we've been encapsulating related data? And this is what object-oriented programming allows you to do. Instead of having what are called structs in C, you have what are called objects in Python and certain other languages as well. And those objects are typically defined what's called a class, when a class is really just like a blueprint or a template out of which multiple objects can be made. And specifically, in the context of this here example, we could consult the documentation for the functions that come with the str object, the string object. And technically, whenever functionality is associated with a specific data type, it's encapsulated inside. It's still a function, but you technically call it a method in that case instead. So a function is what all we've been discussing in C and in Scratch. In Python, you still have functions, but if those functions are associated with a data type tucked away inside of them, then they're just also called methods. It's a minor nuance there. And among the methods rather that comes with strs or strings is a little something called lower. And there's different ways to go about doing this. So let me go ahead and simplify this list to just be the list of values that I actually care about. So let's suppose that I want to support quote unquote y and quote unquote yes, but I don't care about the capitalization thereof. So I could do this. I could take the s variable, and I could actually let's do this. I can create another variable, t, set it equal to s dot lower, open paren, close paren. So notice the dot operator, just like in C, goes inside of the object. Same thing in Python. But here, I'm not going inside of it to get the person's name or their number or their email address. I'm going inside of it to call a method that just comes with that type of value. So in C, just to be super clear, we would have done to lower and pass in s. Python, in an object-oriented programming more generally, just kind of flips that paradigm and says, start with the variable in question and call its own lowercase method as such. And now if I change this code to t down here and here, and I go in here and I search for lowercase n or lowercase no, and I run this version of agree.py, enter, I can now type in y for yes, capitalized, y for yes, lowercase, y-e-s, all capitalized for yes, y lowercase, capital S, like that, any of those variants that exist, and I only have to enumerate canonical versions thereof. Even better, I can kind of tighten this up further. I don't really need a t variable. In fact, I could just do s equals s dot lower and change the value of s to be the lowercase version thereof. What's nice about Python 2 is you can chain method calls together. So if you know that input as a function already returns a string, you don't need to tuck it in a variable before you call that string's lower method, and you can just chain them together in this way. And you could do this sort of again and again. This is not a real function, but you could keep chaining these things together one or more times. At some point, it's going to look stupid because it's just going to be too long of a line of code, and then we get into discussions of style. But for now, having two function calls like this is pretty reasonable, I would argue. And so this just tightens up the code further. All right, so that is perhaps the newest feature that we've now seen of Python, this notion of methods, which derives from this feature of object-oriented programming. But any questions before we take a quick tour of a few other features as well? No? OK. How about a couple more examples, then introduce some loops, and we'll skate our way toward some snacks in just a few. All right. So let me propose that we look at one other problem from our week 4, wherein memory and the fact that it exists and has to be managed by us was creating some underlying problem. So let me open up a program from week 4 that was called copy5.c. At least that was our several iterations in. And that program looked a little something like this. And I'll just skim it for a second. Like, this was getting kind of annoying just to copy one string into another. So I had to use all of these libraries in C. I used Cs50's getString function still, but this is when we took the training wheels of strings off, quote unquote, and started talking about them as char stars. I checked to make sure that S is not null, just in case we're out of memory for some reason. I used malloc ultimately to create more memory, to get more memory for the copy, but still checking if it's null. I then copied the string from one to the other using stir copy. I then made sure the string was long enough, and then I uppercased the first letter in it. Then I printed them out. Then I freed the string, and so forth. Like, it was a lot of work just to make a copy of a string, which in programming in general, it'd be nice if you could just do it more simply. So in Python, here too, it's as simple as that. Let me go into VS Code, open up a new file called copy.py. Then let me put these two side by side. And in the right-hand version in Python, let's do this. S equals input, and prompt the user as before for a string like S, quote unquote. Then let's go ahead and create a second variable called t, set it equal to the S variables, capitalize method's return value, and then print out down here, how about S, and then print out t. Let me open my terminal. Let me run Python of copy.py. Recall that last time when I did HI exclamation point, it capitalized the whole thing, as I recall, as opposed to capitalizing just the first letter. Enter. This time, it works as expected. Now, the print is technically a little different. Down here, I use these format strings. So if I really want to make this identical, I can do F, quote unquote, S, colon, and then plug in the value of S with curly braces. F, quote unquote, T, colon, T. This looks uglier, but it's just now printing out prefixes here, S and T respectively. So if I run this again and do high in all lowercase, it capitalizes it correctly for T and only for T. So here, more so than ever, 33 lines of code at the left, 6 lines, 2 of which are blank at right in Python. Questions about this here example? Yeah? Those blank lines, do you mean get rid of the blank lines? Oh, you absolutely could. I have been doing this visually just to kind of make related chunks of code stand out. So I got S, then I capitalized T, and then I printed them both. But yes, you could totally format this in different ways, just as I did at left as well. Other questions about what we've done here? No? All right. How about this? Let me propose that in C, we also at one point tried to just uppercase everything in a string. So let me open up what was a program called, from week 2, uppercase .c, or really version 2 thereof here. And this was a program that looks a little cryptic, but all it does was ask the user for a string, the before version. It then printed out after colon as just a placeholder for an uppercase version thereof. We then use strlang and this for loop to iterate over all of the characters in the string. And then one at a time, we use the C-type libraries toUpper function to capitalize them again and again. So you can probably imagine where this is going. We don't need toUpper anymore. We can just use .upper in some way. But we do need to have the ability to do things with loops. So in Python, we still have loops, but the syntax is going to be a little different and, frankly, a little easier ultimately. So in Scratch, if you wanted to repeat something 3 times like this, you could implement it in C very mechanically, so to speak, like this. Create a variable I, increment it with ++ again and again and again, so long as it's less than 3, printing meow each time. In Python, you can do the exact same thing if you really want by saying variable equals value, but no semicolon, no data type, while I less than 3 colon. So just like conditionals, you don't need parentheses if they're not logically necessary, but you do need the colon and you do need indentation. You don't have the ++, so we have to do the slightly more verbose Python version here. But that's exactly the same idea to implement meowing 3 times. Suppose, though, that we wanted to take a different approach here. We could, in C, use not a while loop, but a for loop. And maybe you're nowadays in the habit of using these a bit more. They're a little more succinct without all of the vertical clutter. But this is how we could implement the same in C. In Python, it's not quite as obvious how to do this, but we could do it this way. We could say for I in the following list of values. And literally in square brackets, as I did earlier, just enumerate one after the other the things I want to check for. Instead of y and yes and no and n, I can iterate over 3 values. This is fine, but just allow your mind to kind of wander, if it hasn't already, into thinking how this could get us in trouble. Like, why is this approach of just enumerating 0, 1, and 2 probably not the best way long term to do this? What do you think? Yeah?
What if you need like a lot of values, like 100?
Yeah, are you really going to go, what if you need a lot of values, like 100 of them? Are you really going to do 0, 1, 2, 3, ... to 99? Like, that's got to be a better, there's got to be a better way than that. If only because it's going to wrap around the screen, I'm going to miscount and screw something up. So indeed there is. You can alternatively use a function in Python called range, which does, as I said earlier, give you a range of values. And if you want a range of 3 values, starting at 0 by default and going up 2, but not through this value, you literally call the range function and say, how many values do you want? And essentially what the range function does is it hands you out 1 value at a time more efficiently than the hard-coded list, which puts them all in memory at once. Range is a little smarter, and it knows how to give you indeed just 1 value at a time. But notice here, I'm using for I in range of 3, which is similar in spirit to C, because I have this variable I. But I'm not actually using I anywhere. Like, I'm not incrementing it. I'm not comparing it against a value. So strictly speaking in Python, this is correct. But stylistically, some people would actually, by convention, change the I to just an underscore character, which is a valid character for a variable. But it's just kind of this visual indicator that, yes, this is a variable because the for loop requires it in Python. But who cares what it's called because I'm never actually going to use it. So you'll see this convention sometimes, but perfectly reasonable to also use I by convention because I means integer, and that's really what's happening anyway. But just FYI, a convention there in Python. So how can we now use these loops in some actual code? Well, let me propose that what we could do here is the following. Let me go back to VS Code here in my uppercase version, and let me quickly whip up a Python version that achieves something quite similar. Let me go ahead and run code of uppercase.py. At top left, after dragging this over, let's go ahead and implement the following. A variable called before, set it equal to the return value of the input function with quote unquote before as the prompt. Then let's just do a placeholder of quote unquote after colon space space, so they lined up in terms of numbers of letters, close quote, comma, but let me do end equals quote unquote, because I don't want a new line to move the word below the word after. So this is just a silly aesthetic detail, but that overrides the default new line to being no new line. Now let's do this. In Python, instead of using this convoluted for loop and the semicolons therein and this constant checking of a conditional, I can actually just do this. For every character, call it C, in the before string, go ahead and print out that character uppercased like that, but don't print out a new line yet. Until we get to the very end, go ahead and print a new line by printing nothing. But by default, I'm going to get a new line. So passing nothing in gives me 1 new line, and that's it. So let me open my terminal, run Python of uppercase.py, hi, exclamation point in lowercase, enter, and I've messed something up. Not intentional, but so be it. Notice the error here. So this is, I can make this work. So there's these things in Python called tracebacks, which kind of trace backwards what you did wrong. And in this case, what I did wrong, as per all of these caret symbols, is C.uppercase is bad. But you probably already know that from earlier. What should have typed? So .upper. So there's a lot of distraction here, but much like Clang's output, there is some helpful information. 1, the file in question is uppercase.py. Line 4 is where I made the mistake. So even though the output is different from Clang's, it is similar in spirit. Specifically, I messed up an attribute error because some string object doesn't have an attribute that is a method called uppercase. All right, well, that's an easy fix, as you noted. I should have written C.upper, delete, delete, delete. And now, let's clear my screen, rerun Python of uppercase.py, enter, hi exclamation point, and there we have the after version thereof. But even here, note that in Python, I'm doing even more work than I need to. This is indeed how in Python I can enumerate all of the I can iterate over all of the characters in a string. Like there's no i's, there's no conditionals. Python will just, on every iteration, update the variable c to contain one letter, then the next, then the next, then the next. It just sort of works the way you would hope. But in Python 2, recall that you don't have individual characters anyway. So technically, I'm kind of wasting my time by doing this one string of size 1 at a time, again and again and again. I can tighten all of this up here. And I can just, for instance, do this. I can go ahead and print out, for instance, before.upper, and just uppercase the whole thing all at once. And then I could technically get rid of the new line, but now I'm just wasting my time too. Let me get rid of all of this. Let me go over here, and let me output, for instance, let me create a variable called after equals before dot upper. That's going to store in the after variable exactly what I want all at once without even using a for loop. And now I can print out, as before, an f string saying after colon space space, and then the value of the after variable. So this, if I run it again, Python of uppercase.py, enter, hi in all lowercase, enter. That too now works. And one final flourish, strictly speaking, you can interpolate the value of what's returned from a function as follows. Instead of even bothering with a variable here, I could put a modest amount of code inside of the curly braces. And I say modest because if this gets too long, it's just going to confuse everyone, yourself included. But in this case here, I can run this one more time, type in hi in all lowercase, and that too now works because I'm formatting it as an f string. So in short, I'm just getting more and more features at my disposal that I can now use to solve some of these same problems. So that there was a lot. Let's go ahead and take a 10-minute break with some fruit by the foot, and we'll be back with more complicated problems. All right, we are back. So let's go and use some of this new syntax to actually make a meowing cat, albeit textually in Python. So back here in VS Code, I'm going to go ahead and create a program